Neurostimulation refers to the use of various techniques and technologies to directly influence neural activity in the brain. The goal is to modulate brain function and improve cognitive abilities, such as memory, attention, and learning. Neurostimulation techniques involve the application of electrical or magnetic impulses to specific areas of the brain. While research is ongoing, some forms of neurostimulation show promise in enhancing cognitive function. Here are several types of neurostimulation and their potential effects on cognitive abilities. Transcranial direct current stimulation, TDCS. Mechanism. TDCS involves applying a low electrical current to the scalp through electrodes. This modulates neuronal excitability by influencing the resting membrane potential of neurons. Potential effects. Studies suggest that TDCS may enhance learning, memory, and attention. It is being explored as a potential tool for cognitive enhancement and rehabilitation. Transcranial magnetic stimulation, TMS. Mechanism. TMS uses magnetic fields to induce electrical currents in specific brain regions. It can either enhance or inhibit neural activity, depending on the stimulation parameters. Potential effects. TMS has shown promise in improving working memory, executive functions, and mood. It is being investigated for its therapeutic potential in various neurological and psychiatric conditions. Electroconvulsive therapy, ECT. Mechanism. ECT is a more invasive form of neurostimulation involving the induction of controlled seizures. While the exact mechanism is not fully understood, it is believed to influence neurotransmitter release and neuroplasticity. Potential effects. ECT is primarily used in severe cases of depression and other mental health disorders. It can lead to improvements in mood, cognitive function, and overall mental health. Deep brain stimulation, DBS. Mechanism. DBS involves the surgical implantation of electrodes into specific brain regions. These electrodes deliver continuous electrical pulses to modulate neural activity. Potential effects. DBS is primarily used in the treatment of movement disorders like Parkinson's disease. Research is ongoing to explore its potential in enhancing cognitive function in conditions like Alzheimer's disease. Vagus nerve stimulation, VNS. Mechanism. VNS involves the electrical stimulation of the vagus nerve, a major nerve that connects the brain to various organs. This indirect modulation of brain activity affects neurotransmitter release. Potential effects. VNS is used as a treatment for epilepsy and depression. Studies also suggest potential cognitive benefits, such as improvements in memory and attention. Functional near-infrared spectroscopy, FNIRS. Mechanism. FNIRS measures changes in blood oxygenation in the brain, providing an indirect measure of neural activity. It is non-invasive and uses near-infrared light. Potential effects. FNIRS is used in research to study brain function during cognitive tasks. While not a direct form of stimulation, it can inform our understanding of cognitive processes. Optogenetics. Mechanism. Optogenetics involves genetically modifying neurons to respond to light and then using light stimulation to control neural activity. Potential effects. While primarily a research tool, optogenetics holds promise for understanding and manipulating neural circuits. It has potential applications in cognitive enhancement research. It's crucial to note that while these neurostimulation techniques show promise, they are still in the early stages of research, and their long-term effects and safety profiles are not fully understood. Ethical considerations, individual variability in responses, and potential risks need to be carefully evaluated. The use of neurostimulation for cognitive enhancement should be approached cautiously, and individuals considering such interventions should consult with healthcare professionals and researchers familiar with the latest developments in the field.